Good morning. Today we are going to cover the second part for 9.4, graphs of other circular functions, and we're going to continue with example number 5. So take the time to paste your cutout and copy the example 5, and we'll start once you are ready. Go and pause it. Now, when we're graphing cosecant and secant functions, the general equations will be exactly the same. First, for cosecant, we have a, and for secant, for both of them, we have a D, which will be your vertical shift. Your A will be your amplitude. We have the B, which will be pi of your period. Once again, your period will be 2 pi over B. And we have the value of C that will shift your graph left to right, that we call a phase shift. Your cosecant function is an odd function, which means that if we take the cosecant of pi over 2, will give us 1. But if we take the cosecant of negative pi over 2, will give us negative 1. And your secant function is an even function, which means that if we take the secant of pi, it will give us negative 1. And the secant of negative pi will give us negative 1 as well. We are going to start graphing the basic part, the basic graph of cosecant. So there's no coefficient for cosecant, so therefore your amplitude is 1. Remember, it's always going to be positive. There's B, there's no coefficient for 1, for x, so therefore it's 1. So your period is 2 pi over B. In this case, B is 1. So therefore your period will be 2 pi. And now we are going to graph. So let's go make an x and y axis. When I graph cosecant, I do want to make sure that I have enough space above and below. I'll make a larger graph. I'll place my y-axis here. Every 4 squares will be pi. So there'll be 1 pi, there'll be 2 pi, this will be 3 pi, and 4 pi. To the left will be negative pi. Next, my amplitude is 1. So I'll go up 1 and down 1. And I want to make sure that I use a pencil for this part, because I'm going to have to go back and erase it, or you can just do it very lightly. Your cosecant is a reciprocal of sine, so therefore I'm going to graph the sine function first. My period is 2 pi, so I'm going to highlight from 0 to 2 pi. And the same way that we did with sine, I'm going to divide it in 4 sections, half, half, and half. And when you graph this, I do want to be able to see the graph of sine along with your cosecant function. And sine, it starts at 0 or at 1. Sine starts at 0. So I'll start at 0, then I'll go up to 1, back to 0, negative 1, and back to 0. And I'm going to do a quick sketch, a very light sketch of sine. And we know the sine is the reciprocal of cosecant, or cosecant is the reciprocal of sine. So therefore, at 0, what's the reciprocal of 0? It's undefined, correct? Because 0 is 0, we can say 0 over 1, and the reciprocal is 1 over 0, which is undefined. So therefore, every time it crosses your x-axis, it's going to create an asymptote. It crosses your x-axis again here, which is the value of 0. The reciprocal of 0 is undefined. Is 1 over 0, which makes it into undefined. It crosses your x-axis here once again. So therefore, that's going to make another asymptote. And now we are going to take the reciprocal of 1, which is 1. Now, if you want to take the reciprocal of pi over 4, remember that the sine of pi over 4 is square root of 2 over 2. The square root of 2 is about 1.4, 1.3, 1.4. So this is 0.7. And we can take the reciprocal of sine of pi. Make sure I have it on radians, so I'll have to go on the mode or setup. And I want to make sure I have it on radians. So now I can take the sine of pi over 4, which should be about 0.7, and the reciprocal of 1 over my answer, which is 1.4. And if you take the reciprocal of 0.5, let's say that'll be 2. You take the reciprocal of this point, it'll be higher. Therefore, your graph goes something like this. The reciprocal of 1 is 1, and the reciprocal of those numbers is right over here. And that is how the graph. And you don't have to go through the entire calculator part, but you should be aware that the reciprocal of 1 is 1, and the rest of the points are over here. Or the reciprocal of -1 is -1. And that is the graph. So the only thing that I'm going to keep is this part. Now, I do want to be able to see your sine graph, and whether you want to leave it there or just slightly erase it, it's up to you. Or you can make your cosecant graph just a bit darker. The last thing that we need to do is find your domain and range. Your domain will be all real numbers. Except for when x. I need to be able to find out how often are those asymptotes. We know that it repeats every pi. I must select one of the asymptotes, which is 0, plus how often do they repeat? Pi n. And remember that whenever we have a 0, we actually don't need it. And most of the time you just will see as pi n, where n is any integer. And how about your range? Your range will be from -infinity up to 1 to -1. Union from 1 all the way to +infinity. So just make sure that you do provide your domain and your range as part of your work. That's it. Example number 6. So graphing cosecant and secant are very similar to graphing sine and cosine, just a few extra steps. Go and copy it down and we'll graph it together. Go and pause it. So first, cosecant is the reciprocal secant is the reciprocal of cosine. So we're going to start with the 2, which is your amplitude. There is no coefficient for the x, so therefore your period is equal to 2 pi over b, which is 1. So therefore that is only 2 pi. And the pi over 3 is your phase shift. That means that we're going to shift everything negative pi over 3. Now, because of this third, we want to make sure that we place every 3 squares will be 1 pi. And I just need to do 1 period. Actually, let's just do 1 period. On the next one, we'll do a few more. I need to shift it to the left, so I need to have a little space, not too much. I just need 1 block. And my period is 2 pi, so I should have enough by doing it. So once again, because of this 3, I need to make 1, 2, 3 will be pi. It will be making your life much easier if you do so. 1, 2, 3 will be 2 pi. 1, 2, 3 will be 3 pi. Now, my graph will start from 0 to 2 pi, but because I'm going to shift everything to the left, it will be from negative pi over 3 all the way to 5 pi over 3. And I need to decide, my cosine starts at 0 or at 1. You want to do it with a pencil or you just do it nice and light. Will be at 2. I need to divide this in 4 sections, so that is the little more tricky part. Let's see, from here to here, there are 2, 4, 6, so halfway. Halfway is here, and halfway is here. Make sure we keep track of that. So at 2, 0, negative 2, 0, positive 2. So therefore my cosine graph will look something like this. Come down, pick this up, and curve. That'll be the cosine of this function, shifted to the left 3, amplitude 2, period is 2 pi, which is 6 squares. But now I need to be able to graph my cosecant, so therefore every time it crosses your x-axis, the reciprocal is undefined. The reciprocal will be undefined. Therefore, my graph is in this section. Now for cosine, notice that it looks incomplete when we graph only one period. Same thing with your secant. It's going to look incomplete, so it's only this part of the graph, not the second part, and only this part of the graph. So you can go and lightly erase your other graph, but I do need to be able to see it enough that I know that you graph your cosine. And that is the graph of cosecant. Now let's go and write down your domain and range. will be all real numbers, except when x is equal to. So where is this asymptote? We know that the repeat, your asymptote is going to repeat half of your period, which will be pi. But where is this asymptote? This was 1/3, so this will be 1/6. Pi over 6 plus is going to repeat every pi, half of your period, n, where n is any integer. Your range will be from negative infinity all the way up to -2, union from +2 all the way to positive infinity. Now, before we actually continue to the next example, into the last example, one of the things I do want to do, I want to highlight the one period. This is one period of the graph. And notice that for secant, it goes from 0 to 2 pi, and that's what we graph right now. That is one period. And you can have it as dash, your sine and cosine, or you can lightly erase it so I can see it and make your secant just a little darker. Example number 7, and the last example for today. So see if you can graph it, and then we can check our work. Go ahead and pause it. You got it? So let's see. I have my 2. My 2 will be my vertical shift over my vertical translation. We're going to shift it up 2. The negative will be a reflection on the x-axis. There's a 1, so that'll be my amplitude. I do need to be able to factor the 2 before I continue, because that'll be my, and I did not write it down, so let me write down my 2. One factor 2, and this will be x minus pi over 2. My 2 will be my b, so it'll be my period, will be 2 pi over b, which is 2, so therefore my period will be pi. And my negative pi over 2 will be my phase shift, my horizontal shift, which we call phase shift. Now remember that this is your b, it's basically going to be a horizontal shrink, and that's why it's only pi instead of 2 pi. My phase shift is positive pi over 2, so we're going to shift it to the right, pi over 2. I need to do a graph from negative 2 pi to positive 2 pi, so I need 8 squares on each side. 2, 4, 6, 8. 2, 4, 6, 8. I'm going to shift it up 2, so I need a little more space above. So I'll place my graph in here. So let me label my x-axis. 1, 2, 3, 4 will be pi. 1, 2, 3, 4 will be 2 pi. To the left, 1, 2, 3, 4 will be negative pi. 1, 2, 3, 4 will be negative 2 pi. Let me start with my vertical shift. That means I need to make a new midline at 2. So your midline is y equals 2. Now, my period should be from 0 to pi, but I'm going to shift it to the right half a pi, which is 2 squares. So therefore, it's not being from here to here, it'll be from here to here. Still 4 squares, still pi, but I shifted it up to the right 2 squares. And now I can go ahead and sketch it. Let's say my amplitude is 1, so I'm going to go all the way up to 3, all the way down to 1. So I'm going to go up to 3 and to 1. And I need to decide, secant is cosine. Cosine starts at 0 at 1, starts at 1. But because it's reflected on the x-axis, I'm going to start here. It's already divided in 4 sections, right? So therefore, it'll be 1, 0, then 2, then 0, then 1. So it's going to be something in this case. And every time it crosses your midline, it's going to be your asymptote. In other words, that's going to repeat, your asymptote repeats every pi over 2, something to keep in mind. It's always half of a period. And let me just continue on to, actually, let me just graph this part. And then we'll graph the second part. That'll be your secant. That'll be one part, and that'll be the other part. And now we need to be able to graph all the way through. So on the right, 1, 2, 3, 4. I'm going to divide in half, half, half. I'll continue with my cosine, reflected. And then I'm going to go and place my asymptote. Every time it crosses the midline, it's going to be your asymptote for your secant. So therefore, at 2 pi, will be an asymptote. Now on the left, I can fit there are 4 squares, 1, 2, 3, 4. Then once again, I can fit 4 more, 1, 2, 3, 4. Then once again, I can only fit 2, so let me just place them in yellow. Is half. And then I can continue on. So let me go and place my cosine graph. It's going to be here, 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 and here. And again, here, 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 and here. And again, here, here. I do need to be able to see your graph. For cosine. As part of your work, now I'm going to place them all together. Every time it crosses the midline, there's an asymptote. So therefore, the other part is here. And we just have one section here. You can go back and lightly erase your cosine if it's too dark, or you can just leave it as that if it made it light enough. Or you can make a dash as I do on the example. And my screen froze, so let's see what we have. There you go. So therefore that should be your graph. Let's go and do our domain and range. The range is a little bit easier. It's from negative infinity all the way up to 1. Union from 3 all the way up to positive infinity. Your domain is all real numbers except for when x is equal to, we need to select one of the asymptotes. We'll select pi over 4. And then I need to be able to find out how often does it repeat. Remember, they repeats every half of your period, every pi over 2. Where n is any integer. So that will conclude the lesson for today. Have a great day, and I'll see you next time.